Good morning to all the students. Today, once again, I will repeat this derivation, wear strength of gear tooth, and we will solve one problem. Therefore, all the students must be ready with their notebook, pen, and calculator. Therefore, yesterday we have seen wear strength of gear tooth. Wear means removal of material from the surface. Therefore, when removal of material comes into picture, at that time that part or that thing should possess one important property, that is nothing but surface hardness. Therefore, when the contact stresses between the two meshing teeth exceed the surface endurance strength of the material, at that time wear will takes place. Pitting is a surface fatigue failure characterized by small pits on the surface of the gear tooth. In order to avoid this type of failure, the proportions of the gear tooth and surface properties such as surface hardness should be selected in such a way that the wear strength of the gear tooth is more than the effective load between the meshing teeth. The analysis of wear strength was done by Earl Buckingham in his paper The Relation of Load to Wear of Gear Teeth, which was submitted before the American Gear Manufacturing Association in 1926. Buckingham's equation gives the wear strength of the gear tooth. Therefore, Buckingham's equation is based on Hertz's theory of contact stresses. In case of Hertz's theory of contact stresses, when two cylinders are pasted together as shown in figure A, the contact stress is given by sigma C is equal to 2p divided by pi bl equation A, and B is equal to 2p into bracket 1 minus mu square into bracket 1 upon E1 plus 1 upon E2 divided by pi L into bracket 1 upon D1 plus 1 upon D2 bracket raised to 1 by 2, equation B. Therefore, what this Buckingham has considered? Buckingham has considered two gears as two cylinders of diameter D1 and D2, and when the two gears are in contact with each other, the force P is acting on both cylinders so that these two gears or two cylinders will remain in contact with each other. Therefore, when the two forces P and P are acting on the cylinders at the contact point, deformation will be there, and that deformation will be of rectangular shape, and there exist stresses also, and that stress distribution is nothing but of elliptical nature, and width of the rectangular surface is 2b. Therefore, width of the rectangular surface is 2b and its length is L. Now substituting equation B in equation A and squaring both sides, we get sigma c square is equal to 1 divided by pi into bracket 1 minus mu square into P divided by L into 1 upon R1 dash plus 1 upon R2 dash divided by 1 upon E1 plus 1 upon E2, where R1 dash and R2 dash are radii of the two cylinders. Therefore, substituting mu is equal to 0.3, we get sigma c square is equal to 0.35 P divided by L into bracket 1 upon R1 dash plus 1 upon R2 dash divided by 1 upon E1 plus 1 upon E2, equation D. The above equation of the contact stress is based on the following assumptions. First, the cylinders are made of isotropic materials. Second, the elastic limit of the material is not exceeded. And third, the dimensions R1 dash and R2 dash are very large when compared to the width 2b of the deformation. Therefore, these are nothing but radia R1 dash and R2 dash. Figure shows the contact between two meshing teeth at the pitch point. The radia R1 dash and R2 dash in equation D are to be replaced by the radio of curvature at the pitch point. Therefore, this is nothing but radio of curvature at the pitch point. We have considered this right angle triangle, and then we have evaluated R1 dash and R2 dash considering angle sine alpha. Therefore, sine alpha is equal to R2 dash divided by dg by 2. Therefore, R2 dash is equal to dg sine alpha divided by 2. Similarly, here in case of pinion, sine alpha is equal to R1 dash divided by dp by 2. Therefore, R1 dash is equal to dp sine alpha divided by 2. It's like these two equations we are getting. Now, why we have taken radio of curvature at the pitch point? There are three reasons. First reason is the wear on the gear tooth generally occurs at or near the pitch line. When only one pair of teeth carries the entire load, the contact occurs at the pitch point. When the contact takes place at the top or at the bottom of the tooth profile, usually two pairs of meshing teeth share the load, and the dynamic load is imposed on the gear tooth near the pitch line area. Therefore, it is more reasonable to select the radii of curvature at the pitch point. Therefore, by adding the R1 dash and R2 dash, we are getting 1 upon R1 dash plus 1 upon R2 dash is equal to 2 divided by sine alpha into bracket 1 upon dp plus 1 upon dg, equation E. Now we are knowing that ratio factor Q is equal to 2zg divided by zg plus zp. Therefore, substituting dp is equal to mzp and dg is equal to mzg. dp and dg are the pitch circle diameters of the pinion and gear. Therefore, q is equal to 2dg divided by dg plus dp, equation F. Therefore, we are getting finally 1 upon dp plus 1 upon dg is equal to dp plus dg divided by dp into dg, which is equal to 2 divided by q into dp, equation G. Therefore, from equation E and G, 1 upon R1 dash plus 1 upon R2 dash is equal to 4 divided by q dp sin alpha, equation H. The force acting along the pitch line is Pn. Therefore, P is equal to Pn, which is equal to Pt upon cos alpha, equation J. The axial length of the gears is the face width B. Therefore, L is equal to B. Therefore, substituting equations H, J and K in equation D, we get sigma c square is equal to 1.4 pt divided by dq dp dash into sin alpha cos alpha into bracket 1 upon e1 plus 1 upon e2, equation L. A load stress factor K is defined as K is equal to sigma c square sin alpha cos alpha into bracket 1 upon e1 plus 1 upon e2 divided by 1.4. Therefore, substituting the above equation in equation L, we are getting Pt is equal to dq/dpk, equation M. This equation gives a relationship between the tangential force Pt and the corresponding stress contact stress Sc or K. When the tangential force is increased, the contact stress also increases. Pitting occurs when the contact stress reaches the magnitude of the surface endurance strength. The corresponding value of Pt is called wear strength. Therefore, the wear strength is the maximum value of the tangential force that the tooth can transmit without pitting failure. Therefore, Replacing PT by SW, equation name is written as SW is equal to BQ where SW is equal to wear strength of the gear tooth in Newton. SC is nothing but surface endurance strength of the material in Newton per mm square. Above equation is known as Buckingham's equation for wear. Therefore, yesterday we have seen up to this point. Now, if suppose if internal gears are there or the two gears are meshing internally, the ratio factor Q for internal gears is defined as Q is equal to 2ZG divided by ZG minus ZP. Therefore, up to this we have seen yesterday. Now next, we have to calculate value of K also. Therefore, the expression for the load stress factor K can be simplified when both the gears are made of steel with a 20-degree pressure angle. In this case, E1 is equal to E2, which is equal to 20.6 into 10 raised to 3 Newton per mm square. Alpha is equal to 20 degree, and according to G. Niemann, sigma C is equal to 0.27 into 9.81 Bhn in Newton per mm square, where Bhn is the Brenner hardness number. Therefore, K, we are getting it as K is equal to, we are knowing the formula sigma C square sin alpha cos alpha into bracket 1 upon E1 plus 1 upon E2 divided by 1.4. Therefore, write down this. I will wait for 5 minutes because we have to calculate the value of K, which is nothing but K is equal to 0.16 Bhn divided by 100 bracket square. Therefore, write down this slide. Therefore, K is equal to sigma c square sin alpha cos alpha into bracket 1 upon e1 plus 1 upon e2 divided by 1.4. Now substituting the all values, we are getting 0.27 into 9.81 bracket square into bhn square into sin 20 cos 20 into 2 divided by 20.6 into 10 raised to 3 divided by 1.4. Therefore, we are getting K is equal to 0.156 BHN divided by 100 bracket square. Therefore, this 0.156 they have converted into 0.16. Therefore, K is equal to 0.16 into BHN divided by 100 bracket square. The above equation is applicable only when both the gears are made of steel with 20-degree pressure angle. Therefore, we have to use the value of K when, that is K is equal to 0.16 into BHN divided by 100 bracket square when both the gears are made of steel material and their pressure angle is 20 degree. Therefore, write down this and then we will see the problem. Therefore, there are different values of modulus of elasticity and Poisson's ratio for different materials. Therefore, table 8 gives the material properties for the calculation of K. In order to avoid failure of the gear tooth due to pitting, the wear strain should be more than the effective force between the meshing teeth. Therefore, table 8 values of modulus of elasticity and Poisson's ratio for gear materials. First column is material, second column is modulus of elasticity in Newton per mm square, and third is Poisson's ratio. Therefore, for steel, it is 2.06 into 10 raised to 5 Newton per m square. Poisson's ratio is 0.3. For cast steel, it is modulus of elasticity is 2.02 into 10 raised to 5. Poisson's ratio 0.3. For all the materials, Poisson's ratio is 0.3, but modulus of elasticity is different. For spheroidal cast iron, 1.73 into 10 raised to 5. For cast tin bronze, 1.03 into 10 raised to 5. For tin bronze, 1.13 into 10 raised to 5. For grey cast iron, 1.18 into 10 raised to 5. Now, please write down these steps how to calculate module, because there are two types of problems. In case of gear, we have to calculate module, that is first type. or we have to calculate beam strength, wear strength, and we have to calculate power. That is first type. And second type of problem is we have to calculate the module, that is design of the gears. And depending on the module, we have to calculate the dimensions of the gears. Again, we have to check for design. Therefore, these are the different steps to calculate module. Therefore, you write down one by one. I will tell. Step number one, calculate torque transmitted MT from power formula, that is kilowatt. Kilowatt is equal to 2 pi n into MT divided by 16 to 10 raised to 6. Therefore, write down this first step. Then second step, calculate tangential load PT in terms of module M from torque transmitted. Therefore, torque transmitted MT is equal to PT into dP divided by 2, where dP is equal to pitch circle diameter of pinion in mm, which is equal to mZp, m into Zp, and Zp is equal to number of teeth on pinion. Therefore, rearranging the above formula, Pt is equal to, we are getting 2mt divided by dP. Therefore, Pt is equal to 2mt divided by mZp, equation 1. Now, third step is calculate beam strength SB in terms of m square. M means module. Therefore, we are knowing equation of SB. SB is equal to MB sigma B into Y. Therefore, SB is equal to M into 10M into SUT divided by 3 into Y, equation 2, where B is equal to face width, which is equal to 10 times module, that is 10M, sigma B, that is bending stress, which is equal to ultimate tensile strength divided by 3, SUT divided by 3, and Y is equal to Levy's form factor, which is provided in the problem, which depends on the number of teeth. Therefore, write down these steps. I will wait for 3 to 4 minutes. Therefore, next steps are step number 4. If Brinell hardness BHN is given, then calculate wear strength SW in terms of m square. We are knowing equation of wear strength SW is equal to BQ dpk, equation 3, where B is equal to 10 m, dp is equal to m into zp, q is equal to 2zg divided by zg plus zp, and k is equal to 0.16 into dhn divided by 100 bracket square. Therefore, we have to substitute these values, all these values will get SW in terms of m square if Brinell hardness is given. Step number 5. Compare SB and SW and take the value which is minimum of the two for further calculations. Now, whatever this SB value will be there in terms of m square, again SW value will be there in terms of m square. We have to compare these two values, and the value which is minimum, the coefficient for m square which is minimum for SB or SW, that value we have to take for further calculations. Therefore, write down these two steps. Step number 6. Calculate effective load T effective, which is equal to CSPT upon CV, which is equation 4. Now, whatever PT we have calculated earlier, that is from equation 1, that value of PT you have to substitute in equation 4. Value of CS service factor is given to us in the problem, and CV is the velocity factor. There are three values of the CV. CV is equal to 3 divided by 3 plus V for ordinary and commercially cut gears made with foam cutters and with V is less than 10 meter per second. Second, for accurately hopped and generated gears with V less than 20 meter per second, CV is equal to 6 divided by 6 plus V. And third, for precision gears with shaving, grinding and lapping operations with V is greater than 20 meter per second. Therefore, CV is equal to 5.6 divided by 5.6 plus root V, where V is equal to pitch line velocity in meter per second. Now we have to assume V is equal to 5 meter per second in the initial stage, and we can calculate CV. Now this P effective value you will get in terms of M. Therefore, we have to equate effective load, that is P effective of equation 4, to the minimum value of SB or SW. Therefore, when you will equate equation 4 to the minimum value of SB or SW, you will get equation in terms of M cube or M raised to 3, and at last you can calculate value of module M. Therefore, these are the different steps to calculate values of module M. Therefore, write down these steps. I think time is now only 10 minutes are remaining to write down these steps. Once again, I will revise the steps. Then we'll stop here after revising the steps, and problems will start from tomorrow onwards. Tomorrow, college is there or lecture is there. Tuesday's timetable will be observed from, that is, tomorrow. Let's write down these steps. Afterwards, again I will explain. Then we'll stop. Write down. I am taking your attendance. Those who are joined, their numbers are visible to me. Directly I am taking attendance. Therefore, hello, hello. Therefore, once again, I will explain the steps. Now, there will be one type of problem in which they will ask us to design the spur gear. Design the spur gear means we have to calculate module, and based on the module we can find out further dimensions. Therefore, in that, first step is calculate the torque transmitted MT from power formula, that is kilowatt formula. Kilowatt is equal to 2 pi n into MT divided by 16 to 10 raised to 6. Then second step, calculate the tangential load PT in terms of module M from torque transmitted. We are knowing that torque transmitted MT is equal to PT into dP divided by 2, where dP is equal to pitch circle diameter of pinion in mm, which is equal to m into Zp. Zp is equal to number of teeth on pinion. Therefore, Pt is equal to 2mt divided by dP. Therefore, Pt is equal to 2mt divided by m into Zp, equation 1. Then third step is calculate beam strength SB in terms of m square, that is module square. We are knowing that equation SB is equal to mb sigma b into y, where SB is equal to m into 10m into SUT divided by 3 into y, equation 2, where b is equal to 10 times module sigma b is equal to SUT divided by 3, and y is equal to Levi's form factor based on number of teeth which is provided. SUT value is also provided in the problem. Now step 4, if Bernal hardness, that is BHN, is given, then we have to calculate wear strength SW in terms of m square. Again, wear strength SW we are knowing SW is equal to BQ dpk, equation 3, where B is equal to 10 times module, dp is equal to mzp, q is equal to 2zg divided by zg plus zp, and k is equal to 0.16 into BHN divided by 100 bracket square. Now we have to compare the values of beam strength and wear strength, that is SB and SW, obtained from equation 2 and 3, and we have to take the minimum value of SW or SB for further calculations. Therefore, step number 6, calculate effective load P effective. P effective is equal to CSPT upon CB, where CS is equal to service factor which is provided in the problem. CV is the velocity factor. There are three different values of CV depending upon the manufacturing process of gears. Therefore, CV is equal to 3 divided by 3 plus V. CV is equal to 6 divided by 6 plus V, and CV is equal to 5.6 divided by 5.6 plus root V, where V is the pitch line velocity in meter per second. Now in initial stages we have to assume V is equal to 5 meter per second. This is the sixth step. Now seventh step, whatever P effective we have obtained from equation 4 in terms of M, we have to equate it to the minimum value of SB or SW. Therefore, when we will equate, we are getting the equation in terms of M cube, that is M raised to 3, and at last we will get the value of module M. Therefore, these are the steps. Now from next lecture onwards, we are going to solve the problem. Therefore, you must be ready with notebook, pen and calculator. Thank you very much.